So you can design modular construction using the tie force approach. So you may be aware that if you're dealing with light steel frame construction or also timber frame construction, there is a relaxation in the minimum tie force given in the UK National Annex to Eurocode 1 Part 1.7. So normally you'd have a minimum tie force of 75 kilonewtons for internal ties and also for perimeter ties. Where you're dealing with either timber or light steel framing, that minimum is reduced to 15 kilonewtons for the internal tie and 7.5 kilonewtons for the perimeter tie. But of course, your modular construction may not classify as being lightweight. It may be a hot rolled steel frame, in which case you wouldn't be able to take advantage of these relaxations, and you'd be dealing with the 75 kilonewtons. But if you are dealing with entirely light steel frame module, then certainly you can do. However, although it's possible to design modular construction using the tying approach for avoidance of disproportionate collapse, perhaps more oftenly adopted is the notional removal approach, but the notional removal approach is slightly adapted in that it's the notional removal of a module that is often the scenario that's designed for with avoidance of disproportionate collapse. And so a module at lower level is assumed to be removed through some sort of accidental action, undefined accidental action. So the support that that lower module would have been providing is assumed not to exist, and the question is, do the upper modules, the modules above the rest of the building, remain stable? And if they're attached adequately to the adjacent modules and to modules above, then you can get transfer of load, an alternative load path being realized. And if we're dealing with an internal module, then you can have a sort of catenary action or the equivalent of catenary action being realized through those connections between modules. So although you may not be directly following the tying solution for avoidance disproportionate collapse, tying between modules still remains vitally important to achieve avoidance of disproportionate collapse. So that's both horizontal and vertical tying between modules. And that is one of the difficulties with modular construction, though, so not necessarily devising connections that will achieve the tie forces, but devising connections that will achieve the tie forces and that can be physically installed on site. It's of course where you've got potentially 4 or maybe 8 modules coming together at an internal corner where the last module goes in. You haven't really got access to that from the outside. So maybe you might need some internal access or have some method of connection that can be achieved from above, for example. So the connections themselves are certainly easy to design, but making them connections that can be accessed and installed is maybe not so easy.